All right, quadrilaterals, the need-to-know formulas. So here we have a square. We can tell it's a square because all the sides have the same length. They're all labeled with S. This over here is a rectangle. Remember, all squares are rectangles, but not all rectangles are squares. And so the area of a square is just a side times a side, which equals the side squared. The area of a rectangle is a side times an adjacent side, so length times width. They won't be the same number, so we just call it L times W. So really, the square is the same formula. It's the length times the width. It just so happens that the length and the width are the same thing. So that's why we call it S squared. Anyway, memorize these. You do need to know them. More quadrilaterals. These guys are a little more unusual. This is the parallelogram here. Parallelogram. I have to spell my words right. Trapezoid. All right, so parallelograms have two pairs of sides that are parallel to each other, but not with right angles necessarily. So the area of a parallelogram is just the base times the height. The height will be this here. And the area of a trapezoid is a little bit different. So it's actually 1/2 of the height times base 1 plus base 2. You have to take those into account. Or you might see it as B1 plus B2 over 2 times H. It's the same formula. However you want to remember it is fine, but you need to take into account both bases of the trapezoid. So we draw lines to form right angles. You need to know the H to know the area. The height in both cases is perpendicular to one of the bases and goes straight up and touches the other base. It could actually, I mean, it could be given to you outside. Sometimes they'll do it as a dotted line outside the figure. Could have been out here. The height is still the same even if it's out here. But you do need the height to determine the area. There's really no other. I suppose if you had a diagonal, you could have two triangles in both cases, but then you'd still need the heights of those triangles. So having the height for the trapezoid or parallelogram is usually going to be the easy way. Okay, here's the inscribed figures that I've warned you about. So from our database of questions, which of the following statements individually provides or individually provide, because we don't know whether it's one or more than one, provides sufficient information to determine the area of parallelogram ABCD. So remember the formula for the area of a parallelogram, the area is just the base times the height. So we need the base and we need the height. What do we have? Don't forget to read the captions on any photos or diagrams. O is the center of the circle. In parallelogram ABCD, vertices A, B, and D lie on circle O. Obviously C is kind of out there. And AD is the diameter of the circle O, and OD is 4. So if OD is 4, then AO is also 4, and the whole thing together is going to be 8. So the diameter of the circle is 8. That makes that 8 the base of the parallelogram. So we have the base, which is 8. Now all we need is the height. The height would be an imaginary line that we drew here. So we need something that tells us that height. Let's see what the statements give us to see if they give us a sufficient information to figure out that height or figure out the area of the parallelogram some other way. Statement 1 tells us that BC equals 8. Well, we already knew that the base of the parallelogram, which would be the same as the opposite base, was 8, so BC being 8 up here gives us no new information. We already have the base of the parallelogram. We need the height. Choice A, you have done nothing for me, so I am voting you off the island. Choice B says AB equals 4. So if AB here equals 4, that's this line right here. If this is 4, then if we draw a diagonal from B to D, this automatically forms a right angle. If you have an angle that has its vertex on the circle and its 2 points touch the ends of the diameter, it automatically forms a right angle. That's a theorem in geometry. Is it a theorem? I think it's a theorem. Anyway, it's a rule that you can use on the test. Had point B been up here and the two arms of the angle went this way and this way, it would have been a right angle. Had B been over here or over here, from D and then to A, it would have been a right angle. No matter where you put B, anywhere on the circle, if the 2 points of the angle touch A and D, it will form a right angle. as long as B is on the circle too. Okay, so this tells us now that we have a triangle, and it's now a right triangle. If we were to draw it separately, it looks like this. Remember that the area of a triangle is 1/2 the base times the height. The height of this triangle is 4. That's this line right here. We don't actually have the base. The base is the diagonal, and we don't have any way of figuring that out. But we do know the hypotenuse of the triangle, which is 8. We could use the Pythagorean theorem to figure out whatever this is, because 4 squared plus x squared would equal 8 squared. We'd have one side, we could figure out the area of this triangle, and since this cuts the parallelogram exactly in half, we would just multiply whatever that area is times 2 to get the area of the parallelogram, because it's made up of 2 triangles. That's a lot of figuring to do there, but don't be afraid to draw in extra lines if they give you shapes that you're familiar with. It can really make life easier. So AB equals 4 actually gives us a right triangle, gives us 2 triangles that we can use to find the area, and therefore we have the area of the parallelogram. Pretty cool. Let's look at C. C tells us that the length of the perpendicular from B to AD is 2 times the square root of 3. So from B to AD, that's this. It's perpendicular, and it's 2 root 3. That's exactly the height of the parallelogram, the thing that we were originally hoping for from one of the answer choices. So absolutely, choice C does give us the information that we need. So B is in, C is in, A is out. I don't know if I made that clear by crossing it out enough, but crossing it out more. Make sure you don't think it's A. Okay, finally, choice D. The length of arc BD equals 8/3 pi. For this one, I got to clear all this stuff off. So we already selected B and C and not A. The length of arc BD equals 8/3 pi. So that tells us that this arc here from B all the way to D is 8/3 pi. And we know if this were a angle from here, so remember that the angle that forms an arc or a sector is proportional. The length of the arc and the area of the sector are proportional to what the angle is out of 360 degrees. Now we actually can figure out the perimeter of the whole circle. The whole circle, remember the perimeter equals 2 times pi times the radius, but we know the radius is 4, remember? So the circumference equals 8 pi. 8/3 pi, 8/3 pi as a fraction of 8 pi, it's simply 1/3. So this whole thing is 1/3 of the circle. What does that do for us? Well, it may not be immediately obvious. What this tells us is that if this is 1/3 of the circle, this angle, if we were to do it, would be 120 degrees. That still doesn't really do much for us. What it does tell us, though, and this is another one of those theorems of geometry, whatever the angle is that forms an arc, if you draw the angle from the center of the circle, it's that proportion. If you draw it from another point on the circle, so it's actually this angle that forms this arc, this green arc here. If it's this angle, it's 1/2 of whatever that angle would have been from the center. So if this angle forming the green arc is 120, this angle forming that same green arc is 60. And actually then we've made our life easier again, because remember before when we had this diagonal down the middle here, we knew that this was a right angle because of the way that always goes. If you have 2 points on the diameter and another point on the circle, it's always a right angle, no matter how you do it. If this is a 90-degree angle and this is a 60-degree angle, then this must be a 30-degree angle. And we have a 30, 60, 90 triangle. If we know that this then is 8, remember the properties of 30, 60, 90 triangles, the side opposite, I want to use yellow, 30, 60, 90, whatever side is opposite the 30-degree angle, if that's x, then this guy is x times the square root of 3, and this guy is 2x. The side opposite the 90-degree angle here is then 8. This tells us then that this is 4, and this is 4 times the square root of 3. We have all 3 sides of this triangle, and again, that's 1/2 of the parallelogram. We figure out what that area is and multiply it times 2. So, choice D also, against all odds, enough, for us to figure out the area of the parallelogram ABCD. So this is on the hard end of questions. If this didn't look intuitively obvious, just think of this as where you'll be eventually when you're more comfortable with all these elements of geometry.